introduce our next speaker, Mr. Brian Sletten. He is a forward-leaning technologist with a liberal arts education. He's got a lot of unique perspectives and mental models. He is particularly a deep expert with the ideas around linked data, the semantic web, knowledge graphs, machine learning, security. In fact, it would be easier to list the things that this guy does not have deep knowledge of. He's a very good friend of mine. It's my absolute pleasure to introduce Mr. Brian Sletten.
That was very nice. Thank you. And thank you for coming this morning. I apologize. I was not able to make it. Had a family emergency, but glad through the use of modern technology, we can still do this. I've got a QR code up here. If you want to grab that, that will take you to a Dropbox with the slides. I'm also recording this, so somehow the conference will be able to get that to you if you want to go back and check something out. And if you have a question and I don't hear you, please just flag Michael down and maybe Michael can repeat the question or anything, just so we can make this as easy as possible. So thank you for coming. Today we're going to talk about using OpenRewrite and Modern to apply security fixes. But really, it's the talk is about more than that. It's about trying to initiate security efforts within your organization in the first place, because something like OpenRewrite, while helpful, is not sufficient, right? You're not going to end up with a secure environment just because you're using a tool that helps you make some of these choices. So I'm going to start the conversation not talking about that stuff, and then we will have a very brief introduction, because I assume people are generally familiar with the tooling, and then we'll talk in the end about the actual application of the tool to fixing particular security issues. So why do I have to talk about building security in first? Because security is not something that you can just decide to have, right? The security is something that you have to kind of develop in your procedures and how you approach software development and how your organization schedules things and allocates resources, and whether you're spending money on adding features or actually some kind of preventative measure against specific kinds of attacks. And this first section is largely influenced by my friend Gary McGraw, who used to be the CTO of a company in the DC area called Sigital. But he's written several books that you may have seen in the Addison Wesley series. They've got like white hat, black hat security, some yin and yang symbology on it. But his ideas really sort of transcend implementation and are generally good approaches towards the process in general, regardless of whether you're building, Java-based backend services or whatnot. And so the idea here is that software security is not security software. That is, you're not going to buy something or install something to achieve software security. Right? Software security is a discipline that goes into the development of your applications and your systems such that they continue to function correctly, or at least predictably, under certain kinds of malicious attack. And I'll extend this to say it's not just necessarily malicious attack. It's also against accidents and configuration errors and things like that, because one of my early learning experiences, and the worst bug I ever wrote, ended up destroying an RS-6000 workstation because of a sequence of events, and that was not an intentional malicious attack, but there were things that could have been in place to stop it from happening. So the idea is we want to focus on what the system does, and we have a procedure for dealing with that. We call them use cases, right? And tests test the behavior of the use cases, and we know that we've built the system that we're supposed to build when those tests pass. But we need to also start to think about what are called abuse cases, which is the system shouldn't do what it's not supposed to do. And one of the ways that we can do that is with the automation of patching of security bugs and things like that. But it's only one part of the story. And it's we have to figure out from a prioritization perspective, how do we go about deciding, which resources to use and under what circumstances are we going to be addressing those sorts of things. But this really gets us down to a more fundamental question, which is what is security? And the problem there is it means different things to different people. And if you are, working at a company, you may think that your system is secure if they can't read your email, and they may think the system is secure if they can, right? Because you're trying to focus on your own personal privacy, they're trying to stop sensitive data from maybe being exfiltrated out of the organization. So in that case, we've got competing visions about what security actually is, and therefore, it's contextual, and we have to decide what it is we're actually trying to protect ourselves and our users from. So we have to imagine that the security that we can hope to have in a system is a function of the engineering practices, the attempts to define the system, what it is and what it isn't, and how we protect against those things. But it also involves the physical control of the assets on which the software is running. And if you use cloud computing, you've already just ceded a certain amount of security management to the cloud vendor. And so generally we have, confidence that they are working with diligence in secure ways underneath what we're producing. But, to some extent, we don't know. We don't know if some uh, pissed off employee is like, tampering with things or something, under the hoods of our virtual instances. So obviously, there's a certain trust we have to put into our vendor infrastructure, but we have to think beyond just software and bugs. We have to think about who is building the system and who might be interested in attacking the system and why. What value would they get out of doing so? And that's really where it starts to get a little confusing because we can't spend all of our time doing security, but we can't spend none of our time doing security either. And so what we want to do is we want to find some way of defining what good enough is and hopefully put some kind of risk model around it and some metrics around it. And therefore, when we invite the stakeholders to our uh, sprint planning sessions and whatnot, there's a specific set of approaches that we can take towards the decision. Are we focusing on security? Well, let's address the risk that needs to be there versus focusing on features, which will be the constant trade-off. So the question is defining what is good enough, and the answer is unsatisfying, but it's basically better than someone else, right? There's an old joke about two friends who are camping in the middle of the night. They're startled by a bear, and they come tearing out of the tent. And the first one yells to the second one, "Run as fast as you can." And the second one thinks to himself, "I just need to run faster than you." Right? That's basically the best that we can do from a general security posture because you're making it so that the effort to interact with you in a negative, adversarial kind of way is not worth it, right? Because usually somebody wants something out of doing so, whether it's just collecting bots for a denial of service, uh, uh, attack network, or if they're actually trying to exfiltrate data for ransom purposes or industrial espionage or whatever. Like they've got their reasons for attacking you, and if you make it more annoying to do so than it's worth, then they'll probably just go someplace else, unless there's a particular reason why they don't like you, and they're like protesting your dealerships all over the place or something. Like there may be a reason why somebody's coming after you, but you need to know that as well and factor that in and price that into your risk model. So what we want to do is we want to be able to come up with a definition of good enough, and that's going to be where the risk model comes in, because we have to have a mechanism for communicating between the technology and the business people, what that means and what good enough means in that scenario. So we have a potential vulnerability, we have a potential threat, and the combination of those two then yields a potential security breach. So the kind of thing that we're hoping to automate the fixing of are these potential vulnerabilities. So we have to be aware of them. We have to understand what they may uh, look like for our technology choices and our platforms and things. And we have to have a risk model around it to make sure that we understand how likely they are, right? So then the threat is an understanding of threat actors and agents and why they might be coming after us. And we need to put some risk percentages around those as well. And obviously, those two things together compound in terms of the risk. But this is start where we start to get a sense of what's good enough and how much time and effort are we putting into this. And obviously, anything that we can do to automate those kinds of vulnerability reductions is going to be key. So the truth is your organization probably doesn't have anybody who is an expert in categorizing and documenting vulnerabilities. The good news is we can rely on each other as an industry, and at least for the next couple of months, we can rely on the government funded organization that is keeping track of these things. The company MITRE has a contract to manage the CVEs and whatnot, and so uh, tooling and documentation and policy papers and things like that are all driven by an awareness of these vulnerabilities. But fortunately, that's something that you can externalize. It doesn't have to be something that you have to have internally. But then tool chains are going to help us keep track and look for those in terms of dependencies, dependency checks, and whatnot against known vulnerabilities. So to the extent that we can automate these things, that's great. But we still need to have an assessment based on what the actual threat levels are for where we find ourselves. So we also need to realize that this is an organizational issue, and it's not just something for the developers to, can't you just make the system secure? Right? Why can't you do that? Well, because it's very hard, and for all the reasons that I've said and more. So what we need is a policy in place, and that policy is also something that we can hopefully start to automate. Like if there are things like how do we interact with key stores, or how do we manage credentials, or how do we, avoid putting things into uh, our Git repositories that have sensitivity to them, right? Again, these are all things that we would like to be able to automate the application of the security policy, but we need a mechanism to enforce the security policy. And part of that can be in static analysis and code factoring, refactoring. But some of it may also just be in terms of how we address and coordinate and configure our architectural elements. But just because we have a policy doesn't mean we're going to have security. We're going to have to make sure that the policy is being enforced. So there's an assurance mechanism around these sorts of things. And that's where the combination of the initiatives plus the testing infrastructure plus continuous integration and delivery and all these other things that we have can combine in to try to bake the assurance of the mechanisms forcing enforcing the security policy are all part of the initiative that we're dealing with. And that's the part where um, we have to have engagement from everybody in the organization. So we need incentives to make sure that people are able to successfully roll out new features in a secure manner. The problem is generally the people who define the security policies or have sort of final say about security issues are not necessarily the developers. It's very often network admins or DevOps people not directly involved in the rolling out of the business functionality. And their incentive is to keep their jobs. And so, it's easier for them to say no than to explain in 6 months, why they allowed somebody to install some new software or open up a port. So what we need is we need alignment within the organization that says, security is a key part of our goal. We have to have a way of measuring it. We have to have a way of understanding it. And that's where the interactions between the abuse cases and security tests and the building of the system and everything start to come together. So you can see this is an organizational issue. It's an organizational effort to try to tie everything together. Um, and again, what we could do to automate any of it is going to be crucial, and that's one of the things that we'll get to when we talk about open rewrite. Um, the empirical studies done by security academic researchers have identified, obviously, it's not a big surprise, the two main things that we have to deal with: bugs and design flaws. And bugs are obviously implementation issues, and design flaws are factored into much bigger initiatives because obviously the designs are implemented, and we have to find the mapping between the flaw and the implementation and remediate it some way. But what we've found is about half of the issues that we have to address are bugs, and about half of the issues are flaws. And if bugs are so well represented in our tasks of to-dos with respect to security and our systems we're building, then this is where the automation process is going to really give us a leg up because we're going to be able to address a lot of the low-hanging fruit with automated static analysis in our build system, just like we have automated build systems that look for bugs of a logical nature, or if there's incompatible versions in a dependency, and two versions of a class are showing up or something. Those things are relatively easy to address once we have found them, and the value proposition of the open rewrite modern mechanism as one possible path towards that is going to help us not only identify them, which we've been able to do with systems like PMD and Secure Assist and whatnot for a while, but to actually do the work to apply a patch to the system to address them is key to fixing these. So if half of our problems are bugs and half of our problems are flaws, whatever we could do to automate the handling of the bugs is going to be a huge way of addressing the low-hanging fruit. And so this is again why this is only part of the strategy, but it is an important part of the strategy. And honestly, I've worked with a couple different systems, including for a client that was building something kind of along the lines of what Modern does with its security-based rules. But this is a broader approach to patching and modifying software in general, which is a much bigger vision than the customer I was working with. Um, so we find ourselves, wanting to spend more of our time addressing the flaws because they can have much bigger scope and take a much longer time to deal with. We have to look at the architecture. We have to look at, a variety of design issues. And you can see here just when there was a design flaw discovered in TLS, it was originally discovered in 2009, and they had a draft solution before the end of the year, and then the official RFC came out in about a year after the discovery, and it still takes another year and a half for all the major implementers to implement the fixes in the design problem, and then you still have the issue of waiting for users to adopt the new version of the fixed version, right? That's one of the reasons why browser vendors stopped letting people, avoid doing upgrades because of the importance of the security patches that needed to be applied. So again, the goal, if half of our problems are bugs, anything that we can do to automate the addressing of those and the remediation of those is crucial. Because the other part of this is not just identifying them and removing them, but hopefully having feedback loops so that people learn in the process, right? If I'm checking in faulty code and that faulty code has security issues related to it, um, I want the build to break, and I want the build to break for the same reasons that I want it to break if I check in, bad logic that ruins, somebody else's code and causes problems. Number one, when I check it in, if it fails immediately, I know where I've been working. I know what I've been working on. I know what classes and files and things were involved. It's going to be easier to get back into the process to address it right away. So rather than waiting for um, towards the end of a sprint or something when people are checking stuff in and suddenly our velocity tanks because of integration issues, the continuous integration process is about minimizing the impact of these integration issues as individual developers are completing their own tasks. And so we want to have the same benefit with security issues. If you check in a security issue, we want to catch it when you do that, not necessarily, sometime in production. And so it's earlier in the process. We know what we've been working on. It's easier to fix, and hopefully with some automation, some of them can be automated in the process. But the other part of breaking the build is a social one. It is a feedback mechanism where you're the butthead because you just broke the build, and we want to avoid being the butthead. So you learn from the process. And so any system like this that is automating the tool uh, fixing through some kind of code remediation mechanism, we're going to want to be very clear about what it is doing so that people can go through and see like what did I do wrong and how did I fix it and why should I fix it. All of that is addressed in the tool chain and documentation and everything that we're talking about as well. So, just to kind of summarize the process, Gary's building security and maturity system um, involves three main parts. It's the risk framework, which helps us decide what's the likelihood of the individual threats and vulnerabilities, which is going to help us from a prioritization perspective. There's the touch points, which is how do we actually tie these activities into our software development lifecycle. And because people have different processes, the approach is largely process agnostic and focuses on the artifacts, tests, designs, architecture, code, etc. But the third part is knowledge. You need people who know what they're doing. You need people who can identify these things, and that's the hardest part, right? You can build, buy, or rent these people, right? If you buy them, you go out and try to hire them, but that's difficult to do because there aren't that many of them, and most of them are slightly sociopathic. You know, if you've dealt with people in the security industry for a while, they're a little off, and they also get bored easily, right? So there's a good chance that they're gonna come work for you for a little bit, then go move on somewhere else. So that's not a great winning strategy overall. You just end up spending a lot, and you know, it's not clear how much you're going to get out of any individual hire. Then there's the renting strategy. You bring in a consultant, and that can obviously help. But if there's no knowledge transfer, then you're just going to keep on paying that rent over and over and over again, which is fine by them, but it's not effective in terms of how your organization is learning. That's why having tool chains that are aware of the risks and have some way of addressing them and be clear about what they're doing is so important towards the knowledge transfer and the learning process so that people stop this from happening uh, as often as they can by improving their own skills in the process, right? Oh, okay, I see that's a problem. Hopefully, I won't do that again. Um, but I think the more effective strategy is to build these people, right? Hire from within, um, change your organizational alignment so that security is not considered like punishment or some sort of dead end job as a software developer. It's got to be part of the advancement structure, and it's got to be seen as a worthy career, and then train people to have the skills to apply tools and techniques like this that can be very effective. And that often gets pushback from organizations like, well, what if we hire them and they leave? I always ask them, well, what if you don't hire them, or what if we train them and they leave? And I say, well, what happens if you don't train them and they stay? Right? That's not a better situation. Um, so again, the knowledge part is probably the hardest part because the typical developer is, already dealing with learning new languages and architectures and tools and frameworks, and things are changing all the time. Um, and now we expect them to be security people as well. That's a hard ask. um, it's an important part of your career development as a software developer to start to take on some of the mantle of security, just like we had to do so with data and data management, just like we had to do with testing, just like we had to do with automation and ops through DevOps. We now need to bring some of that in with respect to security to our daily activities. So the more we can automate, the more that we can address these sorts of things and enforce the policies, the more likely that we are going to have success as an organization trying to uh, elicit security from the systems that we're designing and building. So just to wrap it up, we need the risk management mechanism as a business level decision support tool. It sounds fancy, but it could just be a spreadsheet, right? It could just be something that says, here are the risks that we've identified. Here's our remediation strategy. Here's the likelihood that they're going to happen. Here's where we decide when to attack them or when not to. So that's just a part of the scheduling process. But the risk model has to be based on an awareness of actual vulnerabilities from the languages that you're using, from the frameworks that you're using, from the operating systems that you're using. It has to have an involvement of the expected threats and the protection mechanisms against them, and the assurance model that the protection mechanism is applying the policy that we're thinking about. So there is some deep understanding that has to happen or organizationally and from a project perspective. But the easiest and most common way of getting some of that is to do what's called an architectural risk assessment. And this is just an attempt to identify the pieces of your system, how they come together, how data is produced in the system, and you go from there. I spent many years helping Marriott protect their use of credit cards by doing an architectural risk assessment of all of their software systems with respect to the use of credit cards. And once I had the diagrams that reflected the actual lay of the land for their systems, then I was able to go through and assign threat models. What happens if somebody is able to break into here? What risk do we adopt by not addressing this at this location, right? So that kind of architectural risk assessment is where you start to do the thinking about the actual threats that you face. And then when you pair those with the potential vulnerabilities, we start to, you know, make material progress on protecting our system against the things that are more likely to address us. So, as I said, this is a process agnostic approach. The idea is to focus on the artifacts, and everybody has requirements and use cases and architecture, whether they designed it or not. They have one. Um, there are tests and test plans. There's the software elements, and then there's the feedback from the deployed systems. The most useful things you can do are to adopt strategies like defense in depth, and that just means you don't rely on any particular security feature or control, but you have a collection of them that work together so that if one misses an attack of some sort, the other ones will start to pick up the pieces and help assess that. For example, velocity checks for your API usage or your service calls or your microservices give you a sense of how the system breathes, and if those start to accelerate unexpectedly, then there's a good chance that you have a security or a denial of service attack going on. So that's where the feedback from the deployed systems becomes so useful. So to start with, we just want somebody who didn't design the system to look at it, because cognitive biases and blind spots can definitely happen to anybody at any time. And so just bring somebody else in. Doesn't have to be external, just not part of the project, to take a look at some of the design decisions and see if they notice anything, and then collect information from the deployed systems to feedback into the requirements, because ultimately we are going to need to have our risk model, and our risk model is going to help feed our understanding of what kind of coverage we have from a security testing perspective against the abuse cases that have been identified. Things like penetration testing are useful augmentations to the approach because they may find additional vulnerabilities that we were not anticipating. But we still have to use the risk model to help us decide what's good enough. Are we spending enough time on security versus features? And that's where it really starts to get kind of complicated. So, if we want to address the easiest, lowest hanging fruit in an automated way, and that represents roughly half of the security issues that we have to deal with, then that's job one, right? And that's why getting something like the OpenRewrite or modern toolchain into your build system is so crucial, because not only can you define your own rules and your own security mechanisms that you're trying to enforce, it comes with pre-baked a bunch of community developed and they've developed a lot of security rules that again helps augment the difficulty with respect to knowledge in about these vulnerabilities. And then the way the tools work, they provide enough feedback that there is very much a learning process that happens in the process as well. So once we get something like that in place, that's a big win in most cases very early on. Then we need the risk model, and then the risk model helps us identify what additional activities have to be done. And in the process, we may identify new code patterns and things that we want to encourage or avoid. And that's where the ability to develop your own rules is so crucial, because from a project by project basis, from an industry regulatory compliance, there may be things that don't necessarily bubble up to the general rule base, or at least not as quickly. So having your ability to take the risks that you've identified during the risk analysis process and say, oh, this is a version that we need to use, but we want to avoid using it in a certain way. Putting that kind of tool chain in place is going to be helpful as well. Now, again, this is a big initiative, and it's so much easier just to think like, well, if we just automate the code fixes, that'll be enough, won't it? No, it won't. But the way that you can find some sense of what is enough for your organization is through a building security in maturity model. So this is a free annual report, self-assessment that hundreds of organizations do, organizations of different sizes, and they report the initiatives and the successes and things that they've had over time. So you can kind of see, hey, that organization looks a little bit like ours. This is what they're doing. Maybe we should do what they're doing as well. And that's interesting because the reports are broken down into four sections. Activities that have to do with the governance of the security initiative in the first place. What kind of data do we need to collect to make the decision-making process around um, the risk assessment, and what vulnerabilities do we actually face based on our technology choices and whatnot. So those are about the individual threats and whatnot. The SSDL touch points is how does our software development approach and lifecycle get modified to include these security initiatives in them, and then what are the practices that have to deal with secure deployment of the systems that we have hopefully tested and gone with. So each one of those governance models, or each one of those large organizing approaches, is broken down into further activities. And so you can see under the SSDL touch points, this is basically what I've talked about so far. The architectural analysis, the code review, and the security testing are the key things where the policy gets merged in with the software development activity. And that's just one way of thinking about it. We can think of attack models, because those can be consistent across projects, right? You're still in the same industry, even if you're talking about, one system versus another. So there's going to be some consistency across projects from that perspective. And then perhaps the most important part of this is, once these get broken down into individual activities, there's also a participation rate, which is how you can decide if you're doing enough, because they roll this up into the 12 core activities that everybody does. And if you're not doing those things, then guess what? They're running faster than you, right? So it's a good starting point. So I encourage you to go check out this BSIM uh, site and register. It's free. They don't hassle you other than to say, like, here's some more. Here's an updated version of the report. But it's a great way of getting some visibility into what's good enough for an organization like yours. But the main point is, This approach is organizational. It's not just something for the developers to do. It's about resource allocation and adoption and career paths and all that kind of stuff. But from an approach perspective, what we're trying to do is automate the detection of known vulnerabilities or risks or poor code design around known problems, and that's hopefully going to address a significant portion of the risk that we actually have. So this is why I felt the need to sort of contextualize the adoption of a tool chain like this, but now we can focus on that particular process. Now there is some complexity around the fact that OpenRewrite and the modern tool chain have slight different use cases and things. The OpenRewrite process I'm going to talk about allows you to develop your own rules and adopt many of them. The security ones do require the use of the modern toolchain, um, but they are useful for open source projects, as is. And more than anything, it's a mechanism that's enforcing the application of the security policies that I'm talking about more generally. So this is an implementation choice around the use of those security rules, but you could also build your own versions of those rules if you wanted to around the OpenRewrite mechanism as well. So obviously, just a quick summary. This is the automated refactoring ecosystem from Modern, and it has recipes for migrating code from versions of framework dependencies to fixing security that we're talking about, adherence to particular styles, which makes it easier to have code diffs and things if everyone's following a consistent style. It's well integrated with both Maven and Gradle, and there's the command line tool, so it can be tied into other tool chains quite easily as well. OpenRewrite itself is focused on the Java-based platforms. That's expanding over time, but Modern itself can be used to address, COBOL and C# and other languages as well. Um, so the idea is, if you're just looking for text-based violations, you could, look for certain keywords or certain library usage or something like that. But that's going to be a really flaky and easily broken approach. Easy to implement, but labor intensive and ultimately fragile. The system that I was working with worked at the AST level. So once the code gets compiled into the abstract syntax tree, there's a lot of structure there that can be leveraged, and you could write rules around, the presence of certain dependencies or the presence of certain classes in your dependency graph, or how you're potentially where you're potentially instantiating something. Um, but it's a little bit esoteric in terms of the elements that are there and how do you address the intersection of style, like your expression of your code style, with the parsing of the tree, such that it's easy to go back and manipulate the actual code while maintaining the style, right? And that's why those kinds of systems haven't been quite as effective. The thing that this tool chain brings to the table is this lossless semantic tree, which has annotations around the various elements, including metadata and uh, what style was in place, so that when you come back and you fix something based on a structural issue, you're not unnecessarily manipulating the style in a way that's going to cause issues. And so it's just a really clever combination of approaches to allow the enforcement of policies that are relatively easy to define across a wide range of code bases, um, while maintaining individual project choices of expression in terms of style. So in the OpenRewrite side, the lossless semantic tree is managed in memory. So obviously there's limits to the size of the project that it can be applied to. Um, but the LST is transformed in memory based on the application of the individual edits that are allowed or not. And then the files are updated with maintenance of the appropriate style. And then there's no sort of like persistent rules or anything afterwards. Just the code is fixed, right? Um, and so if you want to try this out, they've got a series of projects and things. You can try it against your own code bases as well, but um, just like when kids are given toys and whatnot, or you want to give them batteries as well, right? So they can try it out. This is just it's nice to have a code base that's got some issues in it that you can suss out from the tool chain without until you gain confidence what it's going to do. You don't necessarily want it running uh, crazy over your own code base. So there's a version of the Spring Pet Clinic project that you can apply um, a migration set of rules to move from like Spring Boot 2 to 3 or something. I don't remember exactly. Um, if you want to add support for the Open Rewrite process to your Maven or Gradle plugins, you just have to add a dependency to the toolchain itself. And then there is a section, say in Gradle, where you can say what rewrites do you want to support. In this particular case, we're just using the basic active recipe for consistent style in terms of how import order is managed. So there's a policy of like local ones and then platform ones and then third party ones or whatever the actual ruling is. Um, and again, it's the kind of thing where you want to have that kind of consistency because again, that makes it easier to do diffs on files without that kind of noise getting in the way and making it hard to see what's actually happening from a logical or security perspective. Um, but it's not the kind of thing that developers want to spend any time on. So just being able to add the recipe to the build system is tremendous. So then there are the tools that are available, the recipes that are available, and the plugins for these build tools give you the ability to say like, what can I do? And so we can see the list of recipes that are available or the styles that you can apply. Um, and so there's a catalog management of the tool chains that are available. And then if you want to run the active recipe, you can have that be part of your check-in process. Run the recipes before you check them in because obviously it's going to hopefully fix any style issues or um, address any security issues in the process if you're using the CLI. So in this particular case, if we ran the order rewrite rule, um, what we see is that it actually goes through and modifies the code. But because we use a CM system, we're not at risk of losing anything. Um, and what we can then do is use our existing CM system to manage the differencing of the underlying elements. So in this case, these files were modified, and you can look at the differences and see the order in which the imports are managed and whatnot was was all that was addressed. So again, we have feedback, we have visibility into what's happening. It's easy for developers to learn from the application of these rules. It's easy for them to adopt as part of their build process. And it has all the characteristics that I mentioned earlier um, that were key to the process. So, I'm not going to go into the details of like writing custom plugins, but this is a useful little walkthrough that shows you like here's some source code, here's how you set up the rules, here's how you write tests to make sure that because again, the rules are just additional code, and we want to test the application of the code to a particular code base. So we can say here's some sample code for you to apply it to. We want to make sure that if it's applied, it's only applied once. It's only applied where it's supposed to be applied. And if we try to apply it twice, it avoids that happening. So this is just a nice walkthrough of the process. And from there, the world's your oyster, and you can set up whatever kind of security-oriented rules that you want, even still using just the open rewrite side of the house um, from what's there. But obviously, our goal is to address the security issues. So we're now going to tackle that from the tool perspective. That does require you to have the CLI installed. So if you go to app.modern.io, register, and then go down to this little help icon over here, you can install either the stable or the staging version of the CLI from there. There's a bunch of recipes and things here as well that you can walk through, but I'll let you explore that on your own. You do need to have a token, even if you're just using the free tool and evaluating it or applying it to open source projects. You still need a token, but you just create one, give it a name, and then you'll use the command line tool to store the token so that it knows that it's talking to a registered user. There's lots of ways of installing. If you go back to selecting here for Windows, for Linux, for Mac OS, you can download it. You can use Homebrew. You can use various other packaging mechanisms. But just like on a Mac, you would say install the mod command line tool, and then the command to apply your token is uh, mod config modern, give it the token that you got, and then that will say four things that come from this project you can use this for. This is just how they're managing the commercial side of it. It's useful against open source and sort of known code bases, um, but obviously there's a lot of value that's being added that they want to be rewarded for as well. The recipes themselves can be downloaded on an individual basis, or you can just say get them all. I will warn you that this takes a very, very long time to go through, and it doesn't always succeed. Like it'll make references to some recipe and it'll 404 or something, but in general, that'll get you most of what you need for the the issues that we're talking about. Again, having some sample projects to play around with is a nice way to get started rather than um, complicating things on your own. So I recommend creating a little directory, and in that directory, you can use the CLI to clone the default projects. So they have a series of default projects that are known. Um, and kind of in known states, which are useful for the learning process. So in this particular case, when I did this, it downloaded 12 repositories in the default collection. Um, you can obviously define your own once you start using it more fully, so other people can play around with your code base or versions of your code base to learn from as well. So it downloads and clones all of these projects locally, and uh, unlike the OpenRewrite side of the house, the CLI side will write the LST to disk, so you can deal with much larger projects and whatnot than fit in memory. Those are not necessarily always built for the sample projects. Um, just kind of depending on how you catch them in their process. So you'll notice when you do the clone and it's pulling the individual projects out, some will just say, "Yep, we've cloned the whole project, including the LST." Other ones will say, "We don't have the LST found here." So you can then tell it to build the LSTs locally, or just to pull down the ones that are available. Maybe they've been updated since the last time you did this, and you just want to download the new versions to pull them out. This is just an optimization as well. It doesn't have to regenerate the same loss to semantic tree every time um, if the code hasn't changed. But if the code changes, obviously there will be a need to update the LSTs. But it's just an attempt to kind of like cache the stuff that hasn't changed and be able to leverage it from a performance perspective. All right. So once we have the tooling in place, once we have the projects in place, once we have the LSTs that we're going to address built or downloaded, then we can start to apply individual rules. The first one that I'm going to talk about is for managing vulnerable dependencies. So we have this very serious problem these days of what are called supply chain attacks. Um, and sometimes people will sneak in malicious code into a particular version of something, and we don't always notice that. And if you're not careful, you just adding the latest version of a dependency to get advantage to certain logic or code, but you're not aware of the presence of that CVE with the version that you're putting the dependency on. So that's where the availability of the government database is so crucial. And while it was originally canceled as part of our recent cost savings initiatives, once the world reacted like, "Are you freaking crazy?" It was put back and at least extended until like the end of the year or something. Hopefully, it will stick around. But basically, there's a series of databases that collect vulnerability information from researchers and store it and make it available. And then that feeds the definition of the CVEs in the tool chains like this. Um, there's an OWASP dependency check build system that does something similar that we'll talk about in a minute. So each one of these dependencies is associated with a particular version, and we can have some control over the build process to say, I only want you to focus on things that have impact on the compile time or the runtime or testing process. You can indicate whether you want to have transitive analysis. So if you have a dependency on something and it has a dependency on something, like how far down do we want to go that process? Um, in terms of adding support, for OpenRewrite itself, we've seen that we can just add in a dependency to that version, but then we can add in constraints on dependencies to say, uh, you know, use this particular version, um, or just this particular version, and then have some kind of indication of why. So if there is some particular hand configuration that you want to add, you can do that. Or you can just use the command line tool, which is what we're going to do in the next couple of slides. So in this case, if you have done the sync and you do have the dependency check recipe installed, you can just run it in the current directory and it'll go through and traverse and find any projects that are there, and then do the dependency check against that. If not, you can install the individual recipes as need be. The other cool thing is through the online app, you can hook it into open source projects. You can hook it up into your own managed projects, and then you can apply these rules against cloud-based services and CM systems. So you can apply them across open source and your own projects as well. So we run the individual recipe against our 12 projects that we've downloaded in our directory, and it'll go through and it'll say, "Oh, wait a minute, that name is used in a couple different places. Which one did you mean?" So you can see one has to do with like NuGet, one has to do with npm, but we're focusing on the Java dependencies here. So we'll select, I want to apply that version of the named recipe. It will then take that recipe and start running it against the results. If there are no changes in the project, it'll tell us that. But if there are changes, we'll see that it will generate a patch. And that patch will then be associated with this particular execution of this particular set of recipes against this particular checked out version of the code. And obviously, it's not going to do anything yet, but this is where you have some options. So in this particular case, it said we found change results on 3 repositories, and there are data tables for 11. So the tool generates reports of all kinds, vulnerability and assessments, the recipe run stats, which files were modified. So if you want to study what happened or what's being changed, the command line tool gives you an easy way of doing that and generating certain kinds of reports out to you. But you can also then do things like um, check out a particular branch and then apply the patches to that branch so that you can, whatever your branching strategy is for dealing with these sorts of things, you can you can very easily isolate the changes so that they're not just sucked into all the other changes that you're working on from like a feature perspective. Um, you can apply the changes, the patches automatically from the last run, um, or apply specific versions or a particular run to say, okay, we did a couple of things, but let's go back and reapply the one from like an hour ago. And then there's also tooling to aggregate the logs together into more easily managed zip files. So if we did this on the checked out projects, you might see something like this. Again, it's the dependency management check that we're dealing with, and you can see that there's a vulnerability in the extreme version that we had a dependency on 145, and it automatically patches the build to use the corrected version of that. In this case, 1421, and then same thing for the Apache HTTP clients. So just stop and think about that for a second. How much time have you just saved, right? Not only is it very fine-grained, potentially, and applied across a range of both commercial and open source software, or your software and whatever dependencies you have. Um, these are very different um, portions of the code base, right? One's a ThoughtWorks dependency for serializing Java objects, and the other is for dealing with HTTP client issues. The likelihood that the typical developer is going to be expert enough in both of those dependencies to be able to identify these themselves is very unlikely. But having a tool that has the visibility into uh, doing this very sort of general reusable set of recipe activities can be applied and catch all range of issues like this. So if you say, study the last report and generate a vulnerability report, um, it will then do so. And in this case, it says, hey, there's a spreadsheet. So if as part of your software development lifecycle, you've got these are the bugs and, keep track of the spreadsheets and, where's the code breaking or who's checking the code in, you can start to do some analysis here and see who's learning and who's not learning and who maybe needs some additional training in the process to avoid doing some of these things. If the individual developers are not doing it themselves, you could do it at a CI/CD pre-deployment kind of project base as well, just to make sure that there's nothing missed in the process. So we can have spreadsheet vulnerabilities of the data tables that the individual recipe provided. So that's a simple one, right? Obviously, there's the known database of vulnerabilities. There's the things that we want to address. But even just that, um, developers add dependencies to projects because they want to have access to the code that the dependency will provide. Um, they're not always thinking about security, and unless they go through and manually check for those known vulnerabilities, there's a good chance that every new dependency could have an issue associated with it. And this is just a tremendously easy way of getting our head wrapped around that kind of risk. And so if we can automate the reduction of risk by catching when we add a dependency that this was a bad dependency, and then automate fixing it, right? That is a tremendous step forward in terms of the risk reduction um, that we're facing. So we can tweak the effort by relying on tool chains like this, and not only that, it can be instructive and pedagogical in the process to help people understand uh, what's going on as well. Beyond that, there's a whole slew of other security-oriented recipes that are available to you through the CLI. Like I said, or you could create your own if you wanted to do the investment there. But there's a whole series of, say, Java security best practices, right? Now we're moving away from project dependencies being the issue to how we're using the Java platform. And this particular recipe will work the same way as everything else, right? You run it by naming it. If it's not installed, you can install it. It's got configurations and things that it's looking for, and so from that perspective, everything's going to be the same for what I just showed you. I'm not going to go over that level of detail for every single one, but I'm highlighting different kinds of problems that could be easily brought into the system. Bring a new junior developer on or something, um, or use um, code generated based on stuff that other people have done in GitHub. It may violate some of these best practices. So the idea here is same code base, yours, or in this case, the 12 that we downloaded, run the Java security best practices check. So it'll go through and it'll say like, all right, I'm looking at each of these projects, and we can see, boom, 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 boom. Here are the patches for each of them. So, this represents a wide range of open source projects from Spring and Netflix and OpenRewrite itself. Um, but we can see that there's a fairly consistent set of violations with respect to how the Java code is being used in this project across these projects. Excuse me. So just as a sample, if we look at the first patch, we can see that it has to do with how it's setting up an XML transformer factory, and there's a good chance that many of you in here have never touched this kind of code, nor do you ever want to touch this kind of code, and therefore you might not know that setting certain attributes has some kind of security impact at this level. Very easy to get wrong, particularly if you're just copying and pasting from something else that got it wrong. So this kind of thing is relatively esoteric knowledge for the typical developer these days. And it's nice that we can just encode that knowledge into a set of recipes and apply it. Another patch in this case has to do with how we're creating temporary files. And so very, very, very different set of security risks. We can apply these patches and fix that. And we have, in this case, the application of temporary files to the development of key stores for managing encryption or digital signatures or something. So obviously, that's something we want to get right. And if we are creating temporary files in a way that makes us vulnerable to certain kinds of hacking manipulation, then obviously this is crucial to improving our security profile as well. And again, the individual developer is not going to necessarily have to know or to look for all these things on their own. He or she can just uh, look at the reports that are generated, look at the code that it wants to fix, apply the fix on a branch, but also hopefully learn in the process why these things are problematic and how not to do it again in the future. So, wide range of Java-based security patches. But the nice thing about isolating them as project dependencies, Java patches, is that if you're not working on a Java project, you obviously don't want to manage, worry about all those recipes. And so we can isolate the time that it takes to do certain kinds of things. Some you may want to do every time. Some you may want to do as part of like weekly builds, because it obviously takes time to run these reports and generates a lot of logs and things. But we have the ability to pick and choose which recipes we want to apply, um, and win in the development process. Now, I mentioned OWASP. This is a security oriented organization that helps people understand um, risks as they become um, more concerning, and as just sort of here's a tangible set of things that you can do. Avoid these top things because they have the highest risk. They've gone through and done some of the risk analysis from the vulnerability perspective, um, based on looking at other people's code, and this changes from time to time, right? So from 2017 to 2021, things that were important in the past, like XML external entities, become less important once people start using XML less and less. So again, there's a currency to the risk assessments that changes daily, and organizations like OWASP roll those up into known vulnerabilities, and those known vulnerabilities then have um, you know code examples and uh, issues and descriptions of the issues, and what does this look like and how might this happen. So anyway, these top 10 vulnerabilities are managed in a top 10 OWASP recipe. So you can go through and apply the OWASP top 10 as it's currently defined and supported in the toolchain against your code base as well. So very potentially different kinds of issues than basic job security processing. Maybe it's a known vulnerability in a known project or a known vulnerability with a particular way people are doing things. But that getting access to that knowledge through the tool chain without having to be an expert yourself is absolutely crucial towards uh, casting a much wider net over the code base to be able to identify and remediate and learn from the security fixes themselves. Just the other day, I can't remember who it was. Somebody checked in um, AWS key or something into a GitHub repo, and that's a big no-no. And it's also easy to do if you don't set it up properly. You have a place in your code where maybe you look to an external file or something to pull in a key. But if you just like paste it in temporarily, you may forget to take it out, and then you check it in, and then particularly if it's a public repository, um, that's dangerous. But even within your organization, um, if somebody breaks into your system and has access to your repository, then that will give them the capacity to do privilege escalation attacks around the presence of those keys. It's literally like the dumbest thing you can do, and we do it all the time. So having a set of recipes that will go through and address finding AWS secrets, finding Facebook OAuth secrets, or GitHub, or Google, or Mailchimp, or SSH, or Twilio, or Square, or Twitter. Right? This is a lifesaver for these kinds of vulnerabilities that we put upon ourselves because we're not careful about checking this stuff in. So again, I'm identifying a different class of risk packaged up, managed by the developers of the recipes, available to you through the tool chain. It's a value that you get in using these things that would otherwise just kind of go by the wayside. There are recipes that have to do with Spring itself. So if something comes up and we want to, I mean, obviously there's other issues with Spring, like migration from versions or enforcing um, open API dependency endpoints or something like that with a certain style. Those sorts of things exist elsewhere in the recipe toolchain. I'm specifically saying, from a security perspective, there are a couple of Spring related ones to avoid like cross-site request forgery attacks in how you're um, issuing HTTP requests, preventing clickjacking, and etc. So as new vulnerabilities or risks are associated in the Spring specific domain, if you are using Spring, then having recipes like that available to you is obviously of use as well. Um, One part of our strategy is to use encryption, and encryption requires the use of high entropy sources of randomness. Um, at the OS level, the operating systems tend to accumulate entropy through things like the arrival rates of ports on the network interfaces, or perhaps to randomly sample, background noise in the microphone, or hooking it up to a lava lamp or something, right? And if you do not use any high entropy source of of randomness like that, then a lot of cryptographic protection that you think you're getting, you're not going to get. And it's very common for developers to do something stupid like use java.util random instead of secure random, because this is not cryptographically sufficient. This one is. So having the ability to address this kind of problem, again, people will not make this mistake often. So it's the kind of thing like, oh, it doesn't happen very often. You're going to forget about using it, but just having it be part of your tool chain will not only avoid that being an issue, it will stop you from having that become an issue with respect to how you're using encryption. So you're expecting certain protections in terms of secret management because of the use of encryption, but if you undermine that by not using high entropy randomness, then that's a whole nother class of risk that you are now protecting against because of the application of this particular recipe. So I know I'm out of time, but hopefully the idea is more XML parsing vulnerabilities, marshaling objects to and from uh, external representations, the regular expression denial of service. That's one of my favorite ones, um, and things like temporary file creation are among the other recipes. But the process is the same. The tool chain gives you the ability to decide when and where to apply them, and the whole benefit of this is to reduce your overall risk in an automated way that doesn't require you to put a huge outlay in terms of uh, individual training like upfront, but the tool chain will be part of a recurring and continuous learning environment with respect to um, these sorts of security vulnerabilities that the team will be able to learn from over time. So I hope this has been useful as a way of seeing, kind of what's possible and how this is one of the first really material advances, I think, in the automating the reduction of risk for what ends up being about half of the security issues that we have to deal with in a code base. So I'm happy to answer any questions if there are any, but I also know it's lunchtime there, so uh, I'll go ahead and wrap up. All right. Well, I'm going to put the first slide back up, which has the QR code if you didn't get it. The slides are there. Uh, Thank you very much.